Bismillahirrahmanirrahim. This is Nabia Mudassir. In this video, we will discuss on chemical reactions according to heat. If we come to the chemical reactions according to heat, so we can say that we have two types of reactions according to heat. The first one which observe heat during this reaction, and the second one which emit heat during the happening of this reaction, right? So if we come to the types of chemical reactions according to heat, so we can say that we have two types of chemical reactions according to heat. The first one is endothermic reaction and the second one is exothermic reaction. What is an endothermic reaction and how it happened? And what is an exothermic reaction and how it happened? What are the difference between them? In this video, we will discuss on these all things. First, come to the exothermic reaction. Let's know that what is an exothermic reaction. If we come to the exothermic name, so we can say that exothermic reaction is a reaction which emit heat during this reaction, right? It emit heat during this reaction. An exothermic process or reaction, there's no difference between the process and reaction, because in the previous video we discussed on a chemical reaction, and in that video we talked about it, and we said that a chemical reaction is a process, right? A chemical reaction is a process, so there is no difference between the process and the reaction. So we can say that an exothermic process is a thermodynamic process which belongs to heat, right? Or reaction that releases energy or emit energy from the system to the surroundings, usually in the form of heat. While this reaction is happening, so it always emit energy. Usually in the form of heat. It means that from the system, it emit energy to the surroundings, to the environment, right? So we can have this in an example. While CH4 is a gas, right? While this natural gas is burning and is reacting with oxygen and gives us the carbon dioxide plus H2O plus energy. This energy is usually in the form of heat, right? So while this reaction is happening, while the CH4 or the methane gas reacts with the oxygen, while these two are reacting with each other, so during this reaction, heat is emitted. Heat is what emitted or releases. Energy is emitted or releases in the form of heat. So this kind of reactions are called the exothermic reaction. Or for example, Ferium reacts with who? With oxygen, right? While Perium reacts with oxygen, or the iron reacts with oxygen, so it gives us a ferrium oxide. It gives us what? Ferrium oxide. While this ferrium oxide is coming from the reaction of these two reactants, so during this reaction, a lot of heat emits or release, a lot of energy release in the form of heat. This kind of reactions are called exothermic reaction, because in this reaction, the reactants are releasing energy, right? They are not observing. They are releasing energy, right? These kinds of reactions are called an exothermic reaction. Take a look at the graph. In this graph, we can see that here, this is a graph of the exothermic reactions. Here, if we look at the reactants, first the reactants are here, right? These are the reactants. While the reactants are going to react, so first they need activation energy to activate, right? After their activation energy is full, right? So they react with each other. While they react with each other, they make the product, right? This is a process. In this process, this is the graph of their potential energy. This is the graph of what? Their potential energy. The potential energy of the reactants and the potential energy of the product. And this is the reaction progress, right? Here, if we look at the potential energy of the reactants, the reactants have more energy than the product. The reactants have more energy than the product. The product's energy is lower than the reactants. Why? Because in this kinds of reaction, while this reaction is happening, during this reaction, the energy that the reactants had, they release that energy from the system to the surrounding. So the product don't have that kind of energy like the reactants had, because they released energy. So as they release the energy, so now the product is not the energetic as the reactants, because the reactants release energy to the surroundings. These kinds of reactions are called the product. And in exothermic reaction, the enthalpy changes is always zero in the exothermic reaction. Why? Enthalpy is the difference between the reactants and the product potential energy, right? So if the reactants have more energy than the product, while the potential the enthalpy is the difference between these two. So here we can say that here the product have less energy than the reactants. If the product have less energy than the reactant, so if we subtract the reactant's energy from the product, so we get a negative number. We get what? A negative number. Therefore, so we can say that the enthalpy is zero, because enthalpy is the difference between the potential energy of the product and the potential energy of the reactant. So here, if we subtract the reactant's energy from the product, so we get a minus number. So here the enthalpy is equals to minus. So in an exothermic reaction, the enthalpy is always minus, because the product have less energy than the reactant. The reactants released its energy to the surrounding, and the product is less energetic than the reactants, right? Here, if you look at the this graph, look the reactants energy. Look at the reactants energy. Reactants got more energy for the activation. After activation, while they react with each other, so they release the energy. This is the energy level that they had before reaction. And this is the energy level that they have after the reaction. So this energy from the first reactant's point to the last point, this energy is called the energy that released to the surrounding. This is the released energy, right? So these kinds of reactions are called exothermic reaction. After this, I come to the endothermic reaction. That is exothermic reaction. From exothermic reaction, we get that what is an endothermic reaction, right? In an endothermic reaction, this is a reaction, in this reaction, chemical reaction in which the reactants observe heat energy from the surrounding. Observe heat energy from the surrounding to form the product, right? Endothermic reactions are chemical reactions in which the reactants observe. It means here the absorption is happening during the process. The reactants absorb heat energy from the surroundings to form product, right? How? For example, if we can see it in the forming of the nitric oxide. While nitrogen gas reacts with oxygen gas, right? So here the nitric oxide, after this reaction, we get the nitric oxide. We get what? We get the nitric oxide. While this reaction is happening for to form the nitric oxide, we need to give energy to these two gases to come together, and make a new compound, or the nitric oxide. So these kinds of reactions are called endothermic reactions, right? Take a look to the graph. This is the graph of the endothermic reactions. In endothermic reactions, the reactants don't have enough energy. They don't have more energy. While this reaction is happening, so first, for to happen this reaction, they need activation energy. They need what? Activation energy for to react with each other, right? This is the activation energy level of them, and this is the energy level of the reactants. While it reacts with each other, so the product have more energy than the reactants. Look, this is the energy level of the reactants, and this is the energy level of the product. This is the energy level that the reactants had, and this is the energy level that the product have. It means that the product have more energy than the reactants. These kinds of reaction are called endothermic reaction. Why the product have more energy than the reactant? Because the product absorb energy from the while this reaction is happening, so it gets more energy from the surroundings. Therefore, the product have more energy than the reactants. Look at the difference between the product's energy and the reactant's energy. This is the difference between the product energy and the reactant's energy, right? So this is the energy that is observed from the surrounding, right? In this kinds of reaction, in endothermic reaction, the enthalpy is always positive. The enthalpy is always positive. Why? Because enthalpy is the difference between the potential energy of the product and the reactant. So the product have more energy than the reactant. So while we subtract the reactant energy from the product, we get a positive number. We always get a positive number because the product have more energy than the reactant. So if we subtract the reactants from the product, so we get a positive number. Therefore, the enthalpy is always positive in these kinds of reaction. So the reactions that need energy for to happen are called the endothermic reaction. And the reactions that releases energy are called the exothermic reaction. In an exothermic reaction, look at this graph. This is the graph of the exothermic reaction, right? Look at the graph. In an exothermic reaction, here the reactant have more energy and the product have less energy. This can be the graph of the exothermic reaction. Here the reactants have more energy, but the product don't have the energy that the reactants had, right? Why? Because the reactants, while this reaction is happening, so it releases energy. It releases energy to the surrounding. These kinds of reaction are called the exothermic reaction. And look at the second graph. If we come to the graph of the endothermic reaction, so we can have it like this. This is the potential energy, and this is the progress of the reaction, right? In this kinds of reaction, the reactants have less energy than the product. These are the reactants and these are the products. The reactants have less energy than the product. Why? Because why the product have more energy than the reactants? Because they get energy, they take energy, they absorb energy from the surrounding, right? They take energy from the surrounding. Therefore, these kinds of reactions are called the endothermic reaction because it takes energy, it absorbs energy. And these kinds of reactions are called the exothermic reaction because they release energy to the surroundings. These are the types of chemical reactions according to heat. According to heat, we have two kinds of chemical reactions, exothermic reaction and endothermic reaction. The most important things in these reactions, first, in an exothermic reaction, if we come to the main points of the lesson, so we can say that in an exothermic reaction, the enthalpy energy, the enthalpy changes is always negative because the product have less energy than the reactant. So when we have the enthalpy energy, the enthalpy changes means the difference between the product and the reactant potential energy. So while we subtract a big number from the small one, so we always get negative. Therefore, in an exothermic reaction, the enthalpy changes is always negative. But if we come to the endothermic reaction, so in these kinds of reaction, we can say that the enthalpy changes is always positive. The enthalpy changes is always what? Positive. Because if we subtract a small number from the big one, so we always get a positive number. Here, look at this. The product have more energy than the reactants. So if we subtract a small number from the big one, so we get a positive number. Therefore, the enthalpy changes is positive. And enthalpy changes is the difference between the product potential energy and the reactant potential energy. The graph of the endothermic reaction can be this kind of: the reactant have less energy and the product have more energy. In the graph of the exothermic reaction can be like the product have more energy and the reactant have less energy because it releases to the surround and it absorbs from the surround. These are the difference between the exothermic reaction and the endothermic reaction. So by finishing this topic, the video has also finished. Thanks for watching.